Welcome back. Now let us define a few terms which simplifies the process of the derivations pertaining to the second law of thermodynamics. We will define a heat engine, then the efficiency of a heat engine. Then we will define what we mean by a thermal energy reservoir, and then we will go on defining various terms and deriving various statements. The first term to be defined is the heat engine. We will use this term so often that quite often we will restrict ourselves just to the word engine, but whenever we say an engine in this course, it would mean a heat engine. A heat engine does the following. Number one, it's a cyclic device. That means whenever we study it, whenever we ask it to do something, whenever we tap it, start it, it will execute either one cycle or two cycles or three cycles, but it will always come back and stop at its initial state. So whenever we study an engine, it will not have finally in any process a net change of state. It will come back to its original state. So it is a cyclic device. Work is an output. So that means the work done by the engine should be positive requirement. If it does not produce any work or if it absorbs net work, then it is not an engine. It is possible that during the cyclic process, part of the cycle produces work, part of the cycle absorbs work. What we are interested in the net amount of work. If some work is done by the system on some other systems, consider that as positive. Subtract from that some work during some other parts of the cycle which is received or absorbed by the system or some other systems doing work on it. Take the difference of work done by the system minus work done on the system. The net work done by the engine must be 0, otherwise it is not an engine. And naturally, to produce this amount of work, there must be a heat supply to the engine. An engine will generally be shown by a loopy figure, circular or elliptical, just a closed curve with the word engine or simply E inside it. E is sufficient. Okay. It has to produce some net amount of work and it must absorb the required amount of heat. The net amount of heat absorbed by the first law of thermodynamics would be the net amount of work done. But now it is time for us to split this net heat absorption into the positive aspect, that is heat absorbed during some processes and heat which may be rejected during some processes. So that brings us to the idea of efficiency of an engine. Now we come to the idea of the efficiency of an engine. So the full name would be the thermal efficiency of a heat engine. Sometimes the word thermal is replaced by energy conversion. So this may also be the energy conversion efficiency of a heat engine, but short form would simply be efficiency of an engine. Okay. How is it defined? Let us go back to our engine. We look at the net work output. We look at the heat supply, but we now split the heat supply into two parts. Whenever our system, the engine, absorbs heat from some other systems, we will call it heat supplied, or sometimes heat absorbed, but heat supplied is a more common nomenclature. Sometimes the system will transfer heat to some other systems. So, some sort of a negative heat absorption, heat transfer from the system to some other systems. We will call that the heat rejected. So, this is the heat supplied from some other neighboring systems to our system, the engine. This is the heat supplied by the engine or rejected by the engine to some other system, some neighboring systems. Okay. Since we have shown this arrow going in, the positive heat interaction, and this is the negative heat interaction, and since our engine is a cyclic device, the first law would simply become Q supplied minus Q rejected is W net. And this brings us to the definition of efficiency of an engine. The efficiency of this engine, usual symbol is eta, is defined to be the net amount of work done divided by the amount of heat supplied. A subsidiary definition, a derivation from this would be that since W net is heat supplied minus heat rejected, if you substitute for W net and do a step or two of algebra, you will get this to be equal to 1 minus heat rejected divided by heat supplied. Thank you.